Hi, everybody. My name is Emily LaBarge. I am currently a student at Portland State University, and I'm studying environmental science right now. I have a couple years left, hoping to minor in sustainability as well with that. And yeah, through the OASE program, which I won't describe, I think everyone talked about that enough at this point. But through the OASE program, my host company has been Chapul, which is also located in McMinnville. And this presentation will be all about Chapul and what the project that I ran called the Summer Feedstock Formulation Feasibility Trials this summer, which is a mouthful. I'm sorry. I was trying to say it too many times. Is it?
Yeah, just have to select this.
Oh, it's on the screen. Let's go. Okay, amazing. All right, so I'm just going to start off with a general overview of a big problem that we're facing that Chapul is working to address, and that is the problem of food waste and soil degradation in the food and agriculture industries. So just some numbers to throw out for you. About 40 million tons of food waste is sent to landfills annually in the US. And this is, I believe, 1.3 billion globally, which is a lot of food waste. And then food waste accounts for about 58% of methane emissions from landfills, which is a substantial amount. And you can see in this image right here a better way to kind of visualize that as it's created by Chapul, just as a way to kind of grasp how much food this is. And then the other aspect of this is the soil that is losing biodiversity. And there's about 27 billion that's attributed to reduced soil productivity in these industries. So Chapul has a model, a circular model that aims to pilot real food waste solutions in Oregon and the US through insect agriculture, which I don't know if I mentioned that yet. Chapul Farms is an insect agriculture startup. So this means learning how this specific insect called black soldier fly can process food waste and translating that existence of natural decomposers into a more industrial setting and into our food and agriculture systems. So potentially looking at how insects could be this missing link in a lot of the flaws that we're facing. So yeah, this brief overview, food waste comes in, is fed as feed to this black soldier fly larva, and then two outputs from this. It's the larva consumes all of the food waste, and then you have the larva, and then what's they're basically their insect manure, which is this biofertilizer that's really good in agriculture, great for soil health and plant growth. All right, so just a little context on the black soldier fly itself. This is its life cycle. It's about a month total. So the larva in that middle stage takes about a week to eat through food waste, so it's very efficient. Just in a nutshell, to give some context to visualize what that is like. Thank you. All right, so Chapul's solution is taking in these volumes of food waste that are currently going to landfill. Majority is going to landfill. Some are going to other sources, but the bulk of it is going to landfills and being this pollutant that's giving a lot of emissions. So it'll be feeding into this insect rather than a landfill and having these outputs of frass and larvae that then go back into the systems in a loop. All right, so my project scope specifically is this expansion of the current operations at Chapul in incorporating more feedstocks, more local feedstocks throughout Oregon in this future scale up that's being worked on right now in this development of a future facility that will be more industrial sized. Currently, Chapul is operating out of a small research facility that processes about 1 to 3 tons of food waste a week, and we have a local program that's taking in local food waste in McMinnville. My project kind of focuses on phase 2 of this, which is expanding our scope, connecting with more food processors, larger food processors, and starting to look at volumes that are at a much larger scale that will be taken in by our facility once it's operational. Which, for context, that 1 to 3 tons a week that is currently happening, the future facility will be about 50 tons a day of food waste that will be processed. So a lot more. So this project, you can see I have a lot of visuals here of some of the feedstocks, the food waste samples that we picked up, and we're running in these trials to test different formulations and combinations of how we can take this in and put it into the black soldier fly bioconversion process. So we ran 2 rounds of trials. There was the first one, which was initially 8 diets that we formulated. 4 of those focused more on moisture content. 4 of them were more playing with the specific ingredients, things like that. The second round of trials was the 4 best of those. Due to time, we didn't have more, but this project is very much a starting point. I don't have super conclusive results because it was an 11-week program and we're just starting to roll the ball for this expansion of feedstocks and diet formulation. So there were some diet adjustments, but we had 2 main rounds of trials and all of them were actually very successful for this brand new composition of materials. And in these images, for some visual, we have some of the black solidify larvae in the bottom left eating through the diets. And then in the middle, we have those 4 stacks. Those are the initial 8 diets that were run. We have about 2 stacks per diet, or 2 stacks per diet. And then this other one is the second round of trials. It was a larger batch, and that was just after it was mixed and pumped. So that's all the slurry of like 9+ different feedstock waste, rotten food samples, basically, mixed into one that the bugs just got put into. All right, so results, not going to focus too much on this. There's a lot of information on the screen. We had 3 ideal diets that worked really well based on the composition of feedstocks we had that are promising for future trials moving forward towards this future facility. And they were very comparable, especially for a first round of trials, with the current existing Chapul diets that are run weekly. In a nutshell, this slide. So this is my P2 table. A bit different, just because a lot of this is very far out. My emission calculations were based on the volumes that will be diverted and collected from these food processors in the future facility when it's operational. So that 50 ton a day number that I threw out earlier is all of the food waste streams that we collected and used in the trials this summer were ratioed out into that 50 tons. It ended up being about 45 because we have dry ingredients that are added that are not waste streams. So those numbers I scaled up to the annual amount of food waste, which will be taken in rather than going to a landfill or somewhere else, taken in by Chapul's future facility. And then the estimated emissions from this, I used the warm calculator as well to calculate how much will be going of those emissions that would be in the landfill could potentially be reduced. And some caveats with this as well are the black soldier fly operation specifically is not factored into this calculator, which is why those other columns are NA, because at this time it was just the emissions of what it is currently with these food volumes that are going to landfills. So, and the black soldier flies process up to 100% of the food waste that's used. And there's a lot of other factors with the outputs of the frass and benefits there. But so this is a very high level estimated overview of what that emission reduction could look like, but it is still a significant amount. All right, and then recommendations for my company, just in general for future moving forward, continuing to look at seasonality and variability of different waste stocks, or sorry, feedstocks and combining words. So this is important, especially for the future facility, because it'll be able to take in all these different things like food banks who might have some shipment of something that they can't hand out and need somewhere to put it, or things like that, or someone who's consistent, has consistent volumes of large waste streams that need somewhere to go rather than the landfill. So all these, and the different seasons have different waste streams as well. So these factors are all continuing to be considered. We looked largely at summer, some of them were year round, things like that. And then just continuing future diet formulation, doing more repeatability trials on the diets that worked well moving forward, and then just continuing outreach and building connections with more food processors in the area to expand the scope of what food waste can be incorporated and taken into these processes. General personal reflections. I'll try to be quick. I don't know how I am on time. I'm good. Okay. Some challenges. This was a very fast-paced internship. I had a lot of balancing of things I was doing. So there was the feedstock collaboration with all these different companies and coordinating pickups, getting the samples on site. And then I had a lot of split responsibilities between outreach and research. I had a couple side projects as well that are not included in this because time, but a lot of things like that. And then I was doing majority of the hands-on operations of like handling all the feedstocks, mixing all the diets, playing with the bugs, things like that, harvesting everything. So it was a big balance of doing both of those things. And it was definitely problem solving and challenging, but it was really fulfilling and very fun. Super inspiring. And that's one of my lessons learned is like, I've always wanted to do work that has been inspiring and I can see actual change being made. And so it was really, really fulfilling to get to be a part of this summer and see the actual result of what I'm doing and how that can make an impact. Yeah, and bugs are really cool and make a really big difference in the world.
Cool.
Yeah. And then I have me and Caitlin, who was my buddy this summer, up here, and some of my contact info as well.
Okay, thank you so much. Please just put your questions in the chat and we'll get to them at the end when we have